Hi everyone. All right, so we are continuing the topic of inventory management. This is inventory management part 2. So we're continuing, and next topic we talk about is probabilistic models and safety stock for inventory. So the difference between the previous models and probabilistic models is that in probabilistic models, uh, the demand is not constant. So demand is actually basically a function, probability function based on historical data. So we have historical data on how many customers in each day in the past we had, or in the past weeks or past month. Depends on the way that we are managing our system. We use historical data to predict and to use the probability of how many demands are going to be there for us daily or annually or weekly or monthly. Okay, so it is used when demand is not constant or certain. Use safety stock to achieve the desired service level and avoid stock out. So when we say safety stock, what we actually mean is you learned what ROP is. That's your reorder point. That's the point that you know in few days you're going to be out of stock. As a result, you have to place your order in advance. So when you finish all of your items in 1 or 2 sections, the day that that section is empty, your order arrives and you make sure that you have enough stock so that you don't lose your customers. But the thing is, that's only working if your demand is certainly a certain amount or value. But reality is, day by day, things change and people suddenly decide to buy more or less. As a result, we might need to order a little more than what the calculations show us. And that actually is telling us, helping us, in fact, to stay safe in a safe zone of not stocking out at a certain time, a certain range of time. And right here, when I'm explaining what safety stock is, the question is how many more or how much more of certain items should we buy? And since we are talking about statistics and probability theory here, I want to remind you of confidence interval. So imagine that the value of ROP that you calculate is in fact your average or mean, and that can be somehow considered as 99% confidence level around that average. So you're actually, depends on your manager. If your manager wants 99% service level, that means you add enough so that among 100 times of people coming in, 99 of them, you make sure that they can buy the item they want and go. And only one case happens that you are stocking out. So when we say 95% service level, what we mean is among 100 times that people are coming in, 95 of them, at least 95 of them, get the service, or they can buy the items they want, and we don't stock out. So that's the, I can say, the big picture here. So we're going to learn how to calculate that additional stock by considering the fact that the demand can be a probability. So it's not constant value. So how do we calculate the annual stock out cost? And what is the stock out cost? Stock out cost is the cost associated to when a customer comes in and you don't have the item to sell them. Of course, when a customer comes in and you can't sell them, in fact, you're losing the profit of that customer, right? The profit that you could get from that customer is going to be missed. And if you have multiple customers, on even if you sell just one item, you might being able to sell 10 of that item in 1 hour, and in that 1 hour you don't have that item, you're losing 10 times of the profit for each item, right? So that's actually the basic of the idea where we're doing this analysis. So the annual stock out cost is the sum of the units short for each demand level, the probability of the demand level, the stock out cost, and the number of orders per year. You multiply these numbers, that will give you the annual stock out cost. And of course, we want to minimize that, right? So you don't need to memorize that formula. You can always have that ready next to you and just plug in the numbers. So let's look at an example here. And I really want you to pay a very good attention when I'm teaching this. And if you had question in mind, ask. After this example, I will give you one example that you can work on it by yourself and make sure that you have learned it and we can practice it together. So at the beginning, normally when I explain it, 70% of the students will feel confused, and that's very normal. So first time I will explain it, we will talk about it, we will explain it again, and then I'll give you another example that we can work out together and we make sure we understand what we're doing. Okay, so this question is giving us some information. The ROP is 50 units. What that means is the reorder point is 50 units when you have 50 units. What is the cost of stocking out? So stock out per frame is $40. What's the order per year? There's 6 orders per year. But we're not saying how many, we're just saying every year we have 6 orders. Carrying cost or holding cost is $5 per frame per year. So let's understand this table. So this table on the right hand side has the probability of demand and the demand that could happen, right? So these are the possibilities. We could have 30 demands, 40 demands. We could have 50 demands, 60 or 70. What's the reorder point? That's 50. So reorder point is the point where, in fact, your stock hits that point. That means at this point right now, you have 50 units available. And based on your calculation, you know that it's time to put order, right? So right now, how many items do we have? 50. Based on historical data, what's the probability that at this point, 50 customers come in or 50 of these items are ordered and sold, right? The probability is 0.3, 30%. This is based on historical data. So let's say in the past year, every day we did the recording of our stock on a certain time, and one day it was people bought 50. Another day people bought 40. Another day they bought 60. Now, in average, 30% of times in the past year, 30% of times among every 100 days, 30 days of it, people bought 50 items. That's why the probability of people buying 50 items today is 30%. During the past year, based on historical data, 20% of days, people bought 30 items. Another 20% of other days, people bought 40 items. All right, so right now we are at 50 items, and the probability of people coming and buying exactly 50 items is 30%. Now, if 40 items are ordered or sold today, is that a problem for our organization or our sales department? The answer is no. Why? Because we still have 10 items left. If they buy 30 today, are we in trouble? The answer is no. Why? Because we still have 20 items left. So the risk is almost zero here. There's no stock out cost here associated to 30 and 40. Why? Because if they buy 30 or 40, we still have 10 items left. Does it make sense? So how about at exactly 50? What are the possibilities here? There are possibilities of risk here. How about if we add another 10 items to our stock? Of course, that's costly to have more stocks, right? But based on our probability value of 20%, so there is a 20% chance that today 60 people come in, and if you have 50 items, you're 10 short. That 10 short, that's 10 times the stock out cost, right? So there will be a loss there for you. So you want to calculate and see which one is riskier or less risky. You want to see which one is more costly to you, okay? That's what we are going to do here. Okay, so looking at this table, let me explain the table. Let's consider that we have no additional stock addition to the 50. Right now we have 50 stocks, right? Let's say that we don't have any additional stock as a risk control. So we did not buy addition. Is there any additional holding cost? The answer is no, because you don't have additional items, right? So that cost is zero. But what if any of these others happen? You're at 50, you don't have any additional cost, but what if 10 more items are being bought, right? According to the probability of it and the cost of it, so we can come up with a certain amount of cost of not buying additional 10 items. How about if, because in the past we had cases, we had 10% of days, we had 70 items sold. What if that 10% happens today, right? If that happens today, what's the cost to you? 20 items stock out, multiplied by the profit you could make from it, multiplied by the stock out cost, right? So there are two possibilities based on historical data. You could have 60 orders. How many are you short? 10. What's the probability of this 60 happens? 60, 20%. 60, how many addition is it? 10. What's the probability of it? 20%. 40 and 6 are the same for all of these problems. So 6 number of orders per year, and 40 is the stock out cost, which is multiplied by how many items you are missing or you're not selling, right? So, so that's for if there are 60 orders or 60 customer comes in, 50 of them they can buy, we don't have any problem. 10 of them, you will lose them. There is a cost to you on losing your customer. Or, and you remember in probability, or means addition, right? Or means addition. Or it could be 70 people are coming in. How do I know? Historical data shows one of these will happen. So if 70 customers come in, how many items are you short? 20. What's the probability of having 70 customers coming? 10%. So you go down here, look, 20. That's what you are short. What's the probability of it? 10%. And the rest are the same, right? 6 per year, $40 is the stock out cost in average, which is the profit you could make from those items. So this line calculation is nothing but two possibilities. If 10 more customers come in and you don't have 10 additional items, which is 60, or 70 come in and you don't have additional items to sell. So the stock out cost of both, add them up, that's going to be $960. So I want you to recalculate it yourself, make sure you can get the same numbers. Order of operations matter here. So stock out cost, if you don't buy any additional items, addition to your ROP that we calculated at 50, if you don't buy any other stock, the cost to you will be $960. And that's a lot. How about if you add just 10 more items? If you add 10 more items, where do you stand here? Instead of here, you're here. If any order below 60 happens, we are good. We're happy because we have enough stock and we are not having any stock out costs. But the problem happens when you have additional order that you don't have enough items to sell, right? If this happens, how many are you short? 10. That's the 70, right? At 70 orders or 70 customers or 70 sales, how many are you short? 10. That's if you have 10 additional, right? You're at 60. If 70 happens, you're short 10. What's the probability of being at 70? That's 10%. 70, 10%. The rest of the calculation is the same, 40 times 6. Is there any other case that you would be out of stock? The answer is no. There's no other stock out possibilities because higher than 60 is only 70. That's a one case. And what's the cost to it? $240 for stock out cost. But you have additional 10 items, right? Holding additional 10 items has a higher holding cost. How much? Number of additional items, 10, times holding cost, 5. That's $50. So 240 plus 50, here is a 50, right? Here is 50. Why? Because we don't have any safety stock at all. Here we are at 60 because we have additional 10 items as safety stock. So we are at 60. Just let me explain it again. So the first one I said was at 50, right? No additional cost. There are two possibilities. You might have 60 customers or 70 customers. Look, when you are exactly at 50, you could have 60 customers or 70 customers. So I say it one more time. If you have 50 stock, and you know historically, based on historical data, you could have 60 customers today or 70 customers as well. Yeah, if it's less or equal, we don't care because we don't have any stock out costs. But we care about these two. These are the two that can give us loss. And look, so if you are at exactly 50, these are the two cases that you can have stock out costs. If 60 people come in, how many are you short? 10. If 70 come in, how many are you short? 20. What's the probability that you are short 10? You go back up here. That's just the case that you have 60 customers. What's the probability of it? 20%. What's the probability for 70? 70 is 20 short, right? You're 20 short, 70, 10%. So that 0.2 and 0.2 and 0.1, they're the probability of having 60 or 70 customers. Does that make sense? Let's say we have additional 10 items, right? If you have additional 10 items, you're not at 50 anymore. Now you're at 60. Now that you're at 60, anything below 60 happens, we don't care. Even 60 happens, we don't care. There's no cost to it. There's no problem. The only case that we have a problem of stock out cost is 70. How many more are you short? 10 items. What's the probability of it? 10%. 10 items, 10%, right? But you are buying additional 10 items. There's a cost to it. What's the cost of it? 10 additional items times $5 of holding cost. What's the total? $50. Plus the stocking out cost, $290. Okay, so the last possibility is you already know in the past year, based on the historical data, you know that you might have between 30 to 70 customers coming in, right? So you might think of, okay, what if I can hold 70 items? What's the total cost of it? I don't want any possibility of stocking out. Okay, so stocking out is not possible based on historical data, zero cost on that. But there is additional holding cost because you are buying additional items. So that's $20, 20 items extra multiplied by $5 holding cost per item. That's $100 total. What's the total cost? $100 only. So with just $100, you can buy 20 additional items. And as a result, if 70 customers come in, you won't have any problem. Is it always like this? The answer is no. It really depends on the problem. It depends on the costs. It depends on the probabilities. It depends on the carrying cost, stock out cost, and depends on where the ROP is, right? And how many orders per year we have. When these numbers change, we might not have the highest safety stock as the best one. It could fall somewhere in between. And we normally, in real world, we don't have just 5 or 6 items or levels or possibilities. We normally have hundreds of possibilities, and you can create a very big chart and calculate all the costs and see which one is the best for you. There are programs, softwares that actually do all these calculations for you, and depend on which department, which industry you're in, they have their own softwares, but the calculations are pretty much the same. Okay, so any other question on this? Let me pause this. Okay, so what I expect you to do is to read the book. There's one page on this chart, on this plot, that explains what we mean by the minimum, maximum, and average ROP, and what that normal distribution represents. That normal distribution represents the number of orders that they are probabilistic. So if it's constant, that would be that middle point, which is the average or expected value of demand. But here we don't have constant demand. We have probabilistic demand, which means the demand could be anywhere in that range. So you can think of 95% of the demands could be around 2 times the standard deviation around the average, right? 3 times 99.7% is considered in range of 3 times standard deviation around the average. And that's your lead time. So that's on the top is when your stock is full, the maximum stock you have, and slowly you're going to use or sell your items and your stock goes down. At ROP, when at ROP level, you will know that in few days, which is your lead time, you will be out of stock. at ROP point, you know that in few days, or few, depends on the timing, right? A few hours, a few days, a few weeks, you're going to be out of stock. As a result, you need to put your order right here. Now the question is, do you want to put the maximum demand as your order? Do you want to go with the minimum demand, or do you want to go with the average? If you go with the average, there is a probability of stock out. How much? That amount to the right of it. If you go with the maximum demand during the lead time, that would actually cover majority of your, so you have lower risk of stocking out. That would be the bottom part. If you go with the minimum, of course, majority of times you will stocking out, and the probability of having that amount of high demand is actually very high. Okay, but again, please read this this part, read this from the book. There are good information for you to read, and there will be questions. I think 1 or 2 questions will be from there on the exam. So in probabilistic demand, we use prescribed service level to set safety stock when the cost of stock out cannot be determined. So if the cost of stock out cannot be determined, we might be able to calculate the standard deviation of demand during the lead time. And knowing how many standard deviations away from the ROP would give us certain amount of safety or service level, that will actually solve the problem. And we will know with how many addition safety stock we can have a certain service level. So what do we mean by service level? What we mean by service level is if in 100 different times, there are 100 customers coming in. Among 100 customers, how many of them, for how many of them we won't be out of stock? If you say for 70% of them, we will not be out of stock. That's our level of service, okay? So we don't want a customer comes in and we are stocking out. So we try to reduce the risk, which is 1 minus the probability of the service level. So if the standard deviation of your demand during the lead time is provided to you, you can easily just add z times the standard deviation, and that actually can be the amount of your order. Let's see a few examples. So this is another chart. This is actually very good to look at and understand the service level here. So the probability of no stock out, 95% of times. So if you have 100 customers coming in 100 times, right? 95 of them, you have items to sell. And you just want 5%. I mean, that's the maximum. It's a minimum. Minimum 95%, you won't be stocking out. Maximum 5%, you would be stocking out. So that distance is your additional, I mean, the average is the ROP. That distance, how many standard deviation here, that's actually your safety stock. So how many more do you need? And that's your, in fact, Z value. So you will find your Z value multiplied by the standard deviation. That will tell you how many additional stock you need as a safety stock, so that you have maximum risk of 5% stocking out. So let's look at this example. It's saying our average demand is 350 kits. And that's the middle of that curve that we just showed you. And the question is saying, based on historical data, we calculate the standard deviation of demand during our lead times, and that's 10 kits. Stackout policy, the manager says that make sure only maximum 5% of cases happens that people come in and we are stocking out. So service level is 1 minus 5%, or 100 minus 5%, which is 95%. So 95% of times, we want to make sure when customers come in, we have stock to sell. 5% is the risk of stocking out. Using Appendix 1. So you can use the Z table. I provided Z table on the files for you, but you can also use Microsoft Excel if you want. I can show you really quick how to calculate that 1.65. So this is a one-tail test, right? This is a one-tail. So 95% on the left of a Z value. So let's see how we can calculate that 1.65 here. So all you have to do is to, if you want a Z value for 95%, and this is a one tail, right? And here, one tail. Okay, equals to, so you type norm dot s dot distribution. S is for standard distribution. So this is, if you have Z, you can calculate the probability. In this case, we have the probability already. So instead of this, I use inverse. If you use norm.s.inverse, you just plug in the probability, it will give you the Z value. So let me type 0.95. This is a one tail. If it was two tail, you have to add half of the 5% to the 95 to calculate the Z value. So in this case, it's one tail. You just press enter. What's that number? 1.6448. And if you round it, it should be rounded to 3 digits. 645. 645. 1.645. So you see where that number comes from, right? So the question will give you the average, which is this one. Will give you the average demand. It will give you the standard deviation of demand. It will give you the probability of stocking out, or the policy of stocking out, or it will give you the service level. One of these will be given, right? And then you are expected to calculate the Z value and just multiply it by the standard deviation. 1.645 times 10, 16.5 kits. So our reorder point to have a service level of 95% is 350, the average, plus 16.5 of safety stock. So the number is not round. Remember, you always round up for safety stock, because even if it's a 0.1, you don't want that for any low percentage of probability, someone comes in and we are stocking out. So you always round it up to one value higher. And this is very important, because I know in some homework and exam questions, you will have a number like 366.1, and some students round it down and they get the wrong answer. So remember, it's important to know for safety stock, always round up. All right, so the next topic is actually the next three formulas you will see are based on the very same concept. So it's saying when data on demand during the lead time is not available, there are other models available. So when demand is variable and lead time is constant, whatever is variable, right, you have the standard deviation of it. Whatever is constant, is not changing. So we don't need a standard deviation of it. As a result, if demand is variable, lead time is constant, we are going to have the standard deviation of demand and use the same, approximately the same models to get ROP with the safety stock. When lead time is variable this time, so it's opposite of this. Here, lead time was constant. Here, lead time is variable. If lead time is variable and demand is constant, right, then we're going to have the standard deviation of lead time. As a result, we use a different model. We just plug in the numbers and we will get the answers. When both of the demand and lead time are variable, then we will be given the standard deviation of both somehow, and we can just plug in the formula and find the safety stock. Let's see an example here. So for the first one, if demand is variable, right? What do we have here? We have sigma of demand, standard deviation of demand per day. And if we have the standard deviation of demand given to us, we can calculate the standard deviation of DLT, demand lead time. So, which is standard deviation of demand given, multiplied by a square root of lead time. So lead time is given, is constant. Standard deviation of demand is given. You just multiply them and add it to your ROP. So that's your ROP. The average daily demand is given to you. Lead time in days is given to you. You multiply them. That's your ROP. That's your safety stock. Z times sigma of DLT. What is Z? Again, you go to the Z table. Depends on the question. You find the Z value and plug it in. Sigma of DLT, you calculate it this way. Sigma of D times the square root of the lead time. And just plug in the numbers and find the answer. So let's see an example. Saying the average daily demand normally distributed is 15. Lead time is 2. Standard deviation of daily demand is 5. So 15, 2, and 5. Service level we're required is 90%. If you go back and check on Z table, please do it and check if you can find the 90%. You should get a number close to 1.28. This is a rounded number. So ROP will be equal to, the ROP, actual ROP is demand, average demand times lead time, which is 30, plus Z value is 1.28, multiplied by 5, the standard deviation times the square root of lead time, and that is added to your ROP. So ROP plus 9.02 is 39.02, and I told you, doesn't matter how many decimals is left here, you always round up. Okay, so the next type of probabilistic model is when the lead time is variable and demand is constant. So if this happens, how do you do calculations? It's actually very simple. ROP, you get your average lead time and demand, multiply them. Z value, you just learned, you know how to calculate it, right? And just multiply the daily demand, which is constant, by the lead times standard deviation. So there's no specific formula. You just multiply the daily demand and the standard deviation and multiply it by the Z value. So what is the sigma of LT? That's the standard deviation of lead time. I told you, whenever one of these is variable, is changing, the standard deviation will be given. That's the best way to know which formula to use. If the standard deviation of lead time is given, this formula. If a standard deviation of demand is given, the previous formula. If both of them are given, the next slide formula will be used. So in this example, we have a daily demand of 10. which is constant. Average lead time is 6 days. And why do we get average? Because it's a variable. Standard deviation of lead time is 1. Service level required is 98%. Yeah, okay, so the 2.055 is actually coming from table, and looking at the Z table here, you can see 9, we're looking for 0.98, which is between these two numbers. And on the left you have 2.0. On top you have between 0.05 and 0.06. So the book actually used just the midpoint of between these two values, which is between 0.05 and 0.06, which is 0.055. Added to the 2.0, that's 2.055. So the ROP is 10 times the 6 days of lead time. And then we have 2.055, the Z value, times the daily demand multiplied by 1, which is the standard deviation of lead time. And that would be 60 plus 20.55. And we told you that we always round up. So in fact, it doesn't really matter if it was 0.50, it was a 0.55 or 54. Anyway, you would round it up to 81 cameras. And the last one is the probabilistic model, where both of the lead time and the demand are variables, they're changing. So of course, for both of them, you would have the standard deviation. So you can see here, standard deviation of demand will be given to you. Standard deviation of lead time will be given to you. And using these two, you will calculate the standard deviation of DLT, demand and lead time together. How do you calculate that? You just get the average of lead time multiplied by the demand standard deviation squared, plus, and then you get the average daily demand squared, and multiplied by lead time standard deviations squared. And then you add these two, right? Under a square root, that will give you the sigma of DLT. So all you have to do is to multiply the averages of lead time and demand and add your safety stock, which is Z, which you know how to calculate it from the table, and the sigma of DLT that we calculated down here. That would be your safety stock, additional safety stock. Okay, so let's just move to this question. So in this example, both lead time and demand are variable. As a result, we have the average of both. Average of demand is 150. Average of lead time is 5 days, normally distributed both. Standard deviation of demand is 16. Standard deviation of lead time is 1. Service level required is 95%. So we already know that we can use 1.645. The questions on exam will always tell you how many decimals to round to. So I just copied and pasted the formula for this type of problem here, so you can easily, you don't have to go back up there, and the calculations are available here for you. So we have the ROP as 150 times 5. These are the averages of demand and lead time, plus 1.645, which is Z value, times the sigma of DLT. What's the sigma of DLT? We just calculate that. 5 days times 16 squared, 150 squared times 1 squared. And you just calculate and add them up. You're going to get 154. So what is 154? The 154 is your sigma DLT, standard deviation of demand lead time. And your ROP will be, so 150 times 5, which is your averages of demand and your lead time, plus Z value times sigma of DLT. That would be 750 plus 253, which is 1,003 packs additional safety stock for this problem is calculated. All right, the next type of problems that we go over here are the single period model. So in single period model, only one order is placed for product. And why is that? Units have little or no value at the end of the sale period. So these items, they're perishable. After some time, normally a short amount of time, they're not in a quality that you can sell them. They're considered as salvage, right? So things like food, like fish, like meat, like vegetables, fruit, right? After some time, they're going to, the quality is very low and you can't really sell it to people. So CS is for cost. So that's cost of shortage. And cost of shortage is, in fact, you're losing the profit, right, from that sale. So that's the selling price per unit minus the cost per unit. That's, in fact, your profit. CO is the cost of overage, meaning that if the item stays and you can't sell it by a certain time, that's a cost to you because you can't sell it after a certain time. That becomes salvage, right? So that's the cost of buying that unit minus the salvage value. Why we don't put it zero? Because sometimes if the quality of an item goes down because of being expired or after some time it's actually not as fresh as you can sell it. Sometimes you probably, normally what companies do, they sell it to a lower level place or sell it to restaurants. There are restaurants that they buy items after they are expired. I'm not saying it's good or bad, I'm just saying this happens. So you might be able to put it at a lower price and sell it. So that is the selling price after the expiry date, okay? After it's not fresh anymore. So the service level that we just talked about is calculated based on the CS, cost of shortage, divided by the sum of cost of shortage and cost of overage. So it's a very simple formula. Let's see an example here. Average demand is 120 papers per day. Let's say average demand is 120 papers per day with a standard deviation of 15 papers. And the selling price, let's say it's $1.25 per unit with a cost of 70 cents per unit. Now we can easily calculate the CS and CO. So CS is 1.24 minus 0.70, and CO, the overage, is 0.70 minus 0.3. And 0.3 is actually given to you as salvage value for your item. Now, what's the service level? Service level is CS, cost of shortage, divided by the sum of shortage and overage. So which is 0.55 plus 0.4. Add them up, that's 0.95. And the CS divided by the sum of CS and CO will give you 0.579. So what is the 0.579? That's in fact your service level, right? That's the definition of service level by that formula. So our service level is 57.9. Average is 120. Questions say average demand is 120. The ROP is supposed to be 120, right? So how many more? What is our, in fact, optimal starting level? More than the average demand. So that's the inverse, right? Inverse process. So the area is given 0.579. You want to find the z value, right? So all you have to do is to type in 0.579. So if you round this number up, that would give you 20%. That's 20%, right? So the optimal stocking level will be calculated by your standard deviation multiplied by z value. Standard deviation is given, right? Standard deviation. Yeah, standard deviation is a 15 papers multiplied by the z value 0.2. And you're going to have 120 plus 20 times 20% times 15. That would be 3. 120 plus 3, 123 papers. What is that? That is your order point, your reorder point plus the safety stock, which is optimal stocking level, which is 123. Now, what is the risk of stocking out? So we know that service level is 0.579. The risk of stocking out is the opposite of 57.9%. That's 100 minus 57.9%, or 1 minus 0.579, which is 0.422. So the probability of stocking out is 42.2%, which I think is a high value here. But when it comes to perishable items, it's actually a good level.